There are several things that we need to consider when charging RELiON lithium iron phosphate batteries. They work in a very different way to standard lead acid batteries like AGMs, gels, flooded. They will actually take a charge, whatever charge we have, completely for the full length of the charging process. We don't have chargers big enough for them. They will actually suck down the maximum current that we can provide for the total length of the charge, which is very unlike the lead acid batteries, which will take it for a while but then have to tail off into a long acceptance charge until they're fully charged. You can see that on the graph here. This shows where the RELiON battery, the red trace there, takes the 50 amp from our 50 amp charger completely all the way and then just turns itself off basically. Whereas the other one, the Firefly, takes it for about halfway and then goes into that long tail slide while it continues charging. And that is a very low, very safe charge, that 50 amps there. We recommend 100 amp maximum for these batteries. That's a very safe limit. We can go higher. When batteries are put into parallel, when we put two of them together like this and connect the positives to the positive, neg to neg, and then you take your two power wires off from that, or 4 or 6 or how many of these together to make up a bank, increase the amp hour capacity. Then, of course, the charging current and the loads are shared between all the batteries, so they take a very safe, very low current. We have safeguards there, and there is some guidance as to what the maximum charge should be for those banks. That'll be published shortly. So what is the voltage we should be charging these RELiON batteries at? Well, we don't want to go too high, obviously, but other than that, there's quite a wide range. Unlike lead-acid batteries, the charging voltage doesn't affect the length of time of the charge. 14.4, 14.6 volts is a very good safe charging voltage for these. If it goes over that, then there's safeguards built in the electronics inside the battery there, which will cut off the battery if things go awry, and also if it gets too low a voltage. But you can charge at 14.0 volts all the way through to 14.6. It doesn't really matter. At 14, that's about the lowest. Then it's about 99.9% fully charged. And so we recommend the lower than the better. So if you can set your charger to 14.2 volts, that'll be a good safe charge. Now we've been talking about the 12 volt. Of course, we have 24 volt. Batteries, we have them in the small cases and in the 8D sides as well in 24 volt, and then we go on to 48 volt. So no more putting batteries in series, which has always been essential if you wanted a larger battery bank, but not a good way to do it. Batteries get out of balance, and there's a lot of downsides to putting batteries in series. So now we have 24 volt, and of course the charging voltage we were talking about, we double that for 24 volt. Now if your battery charger has a float setting, then that can be used if you don't have the opportunity to change the charging routine from a 3-stage or 4-stage down to a 2-stage, which is the ideal. But if there's a float charge setting in there, that's no problem. Anywhere between 13.3, 13.8 is allowable, and that's a good setting. The problem comes with battery combiners and battery-to-battery chargers. If you had a secondary battery, like the engine start battery or a bow thruster battery, then typically the way to combine those during charging is one of those devices. But they work on a setting where it cuts in so that it sees a charging voltage, and then one where it cuts off and separates the batteries so one doesn't drain the other when there's no charging source. A lot of these are set anywhere 13.3, 13.4, something like that. But these batteries sit at about 13.3 volts when they're fully charged and there's nothing happening. So the settings on a lot of those items may not work, and that means looking at very closely, because you may find that the combiner will combine on and never ever turn off, and then you may have problems. So that's one thing to look at. Another thing is the charger. Your shore power charger, whether it's an inverter charger or a standalone battery charger. Typically battery chargers have 3 outputs, and you can do individual batteries like a starter, a bow thruster, and then the main battery. and each one will work individually. But a inverter charger, which are very popular, and most people have one of those, then you only have one output. So then you have to charge the main battery, the RELiON batteries, and then run the secondary batteries from that through a battery-to-battery charger or a combiner. Alternators will take some real scrutiny when it comes to charging lithium iron phosphate batteries. Because of their voracious appetite for amps, they will suck down anything that we can offer it. Then the alternator is being asked to provide maximum current from output for the total duration of the charge, and most of them are just not built to do that. We have great alternators and regulators now from people like Bauma, which will be able to regulate it and also have a temperature sensor on the alternator case, so that if the alternator does get too hot trying to deliver its full power, then the regulator will cut it down and safe and provide some safeguards to the alternator. But that is something that should be looked at very closely. One very important item to have on board with lithium iron phosphate batteries is a battery monitor. The way these batteries discharge is unlike lead acid batteries like AGMs and gels and flooded. They keep their voltage pretty stable between almost fully charged and getting to the bottom of the charge level. So typically 0.3, 0.5 of a volt, that's the only difference between the two. Lead acid batteries, we can gauge that typically by the voltage, 12.2, that's been the standard, that's about 50% discharged. But you just can't do that with lithium iron phosphate. So you need a good battery monitor, and they will actually monitor and check the amp hours in and out of the battery and give you a very precise reading of how much capacity is left. You can put alarms in there to tell you when it's getting near the danger point. And we offer them from manufacturers like Victron and Felipe. We have several models there, very accurate, and it's essential to have one of those on board and installed properly. So there you have it, some guidelines as to how to charge the RELiON lithium iron phosphate batteries. There's no magic to it. You just got to take some precautions and check all the settings, change them where appropriate, and enjoy the benefits of these incredibly powerful and state-of-the-art batteries with all their safety mechanisms built in. Sit back, relax, and you know what? Enjoy a nice cold drink care of RELiON lithium iron phosphate batteries. Thank you.